notes are on the screen. It's that time again. Here it is, my friends. Video notes are on the screen. Ooh, yeah. Things are gonna get easier. Ooh, yeah. Things are gonna get better. Ooh, yeah. Things are gonna get easier. Here we are again. It's that time, my friends. Video notes are on the screen. Hey everyone, welcome to this week's installment of Video Notes for Mr. Flugum's Physical Science class. We'll be talking about wheel and axle and pulley systems. Obviously that's what it says right here. And these notes will go on page 35 in your Physical Science notebook. Let's go ahead and get started. Alright, you can see the definition of a wheel and axle there. Usually you have a larger wheel, which is where we put our effort force in, and a smaller axle. So remember last week when we talked about work and force and distance, and how force and distance are always a trade-off, right? So remember, when you can use a larger distance for your effort, then you need less force, and you can get more force over a smaller distance with the small axle. So a real common example of a wheel and axle that we use all the time is a screwdriver. The larger handle has the larger radius, right? More distance, so you need less force. Okay, and then the axle is the actual driver part of the screwdriver. Okay, less distance means you get more resistance force out of it. I have a different kind of screwdriver there on the right side. Will this give you a better mechanical advantage? And if yes, then why? Be ready to kind of discuss that a little bit in class on Thursday or Friday. Alright, moving on to pulleys here. You can see the definition for pulleys, and then there's three kinds of pulley systems, right? Fixed, movable, and then block and tackle. Remember, fixed means it's just a single pulley that's stuck in place, right? Whereas obviously a movable pulley can move. And the block and tackle is a series of pulleys, right? Generally, I think of this, a block and tackle is two or more pulleys that are put together into one machine. Alright, well let's move on to mechanical advantage of a pulley. Specifically, we're going to talk about the IMA. Alright, remember IMA stands for ideal mechanical advantage, which is always much easier to calculate than the real or actual mechanical advantage of a machine. Usually this just involves measuring, right? Simple distances. Well, in this case, it comes down to counting. Alright? And it means you got to be able to count the number of rope segments that actually support the resistance weight. Now the diagram I have there, as you can see, the pulley, the rope on the pulley can be easily divided into 1, 2, 3 sections, right? Well, as we look at that, only 2 of those sections, the first 2, actually support the resistance weight directly. The third one is the rope segment that has the effort force applied to it. So in this case, this pulley system has an IMA of 2. So what does this IMA of 2 mean? Well, when we look at a pulley system, all of the ropes that are supporting the resistance weight distribute the weight evenly between them. Alright, so in this case we have 2 ropes, right, that are supporting the resistance weight. Both of those ropes take on half of the total weight. So if we have 100 newtons, each of those ropes only has to take on 50 newtons, right? Distributes it evenly. And what that means is this, then I would only need to apply 50 newtons of effort force to lift that 100 newton weight. Alright, well here's just another example to practice with. You can see this rope on the pulley system can be divided into 4 segments, but there's one you don't count, the one that you apply force to, right? Okay. All the other rope segments evenly distribute the weight of the resistance between them, right? So in this case, we'd have 1, 2, 3 rope segments, gives us an IMA of 3. Now you might be tempted at this point to start thinking, well, hey, there's 3 pulleys, so it must be IMA of 3. Last one had 2 pulleys, must be an IMA of 2. That's not always the case. All right, you have to look at the number of rope segments and how they support the resistance force. All right, last slide here, folks. We got 3 pulley systems here. All right, a fixed, a movable, and then a block and tackle. And what I want you to do is real quickly look at those and see if you can figure out what the IMA is. We'll be discussing this in class on Thursday or Friday, and we'll also be doing a lab on pulleys on Thursday and Friday. So be ready with this, and you're going to have a good head start on those that don't do the video notes. All right? So be ready to discuss this. Maybe write down some ideas or answers right now so that you can tell me what the IMA of these 3 pulley systems is. Thanks for tuning in, folks, and I hope you have a great day. See you on Thursday or Friday.